Then it's code in the data, give the keyboard a punch, then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean, and it's, oh boys, can't you code it? Program it right. Nothing ever happens in the...
This video continues my series on using Stata to visualize data. In this video we're going to look at how Scatterplots work in Stata and learn a few more Stata commands for cleaning up our graphs and making them look nice. I've scattered a lot of these tips about making a nice looking graphic throughout all these videos. I don't have them all in one place. And I'm going to try to make a video on that of how to make a nice, clean, uncluttered looking graphic. The trouble with that is a lot of the Stata commands use different kinds of options, but we'll make that video to give you some of the more common ones that work across all of the Stata visualization commands. You can see I've already got Stata up and running. I've loaded a subset of the General Social Survey. I have data from 2010, and we're going to be looking at the relationship between occupational prestige, given by the variable PRESTG80, and number of years of education. Let's go ahead and look at a correlation of these two measures. And our bivariate correlation shows they correlate about 0.52. So this is a moderately strong correlation, and so there's probably something to be learned by looking visually at the relationship between these two measures. The first thing we're going to do is create a basic scatter plot using very few options. The only option I'm going to use, if you look at line 5, is the option to name the graph, and we'll call this scat1, and again I'm using the replace sub option as I've done in all the other videos on visualization. Now I've gone to using graph two-way for this particular graphic. In graph two-way, the advantage of using graph two-way is that we'll be able to create more than one scatter plot or more than one graphic and superimpose them one over the other. The first example won't do that, and the command here is simply graph two-way, and then in parentheses I declare the type of plot, which in this case is scatter, and I give my y-axis variable prestige 80 and my x-axis variable educ. Let's go ahead and see what this graphic looks like. So this isn't too bad, but you see a common problem with General Social Survey data. On the education variable, there's a limited number of outcomes. Education ranges from 0 to 20. And so we're stacking up over 1,000 cases on top of each other. Stata is literally printing or overlaying thousands of cases, and they fall on top of each other, and it creates this kind of banding effect. So it's a little difficult to see what the actual underlying relationship is. So what we're going to do is we're going to superimpose another kind of plot on top of this. I'm going to superimpose a linear fitted plot. So if you look at line 6, the difference between the graphic created in line 5 and line 6 is I've added this other plot. The way I do this in Stata, there's more than one way to delimit the plots, but I just put them in parentheses. And I think of it as a mathematical equation that I do everything in the one set of parentheses first. So I'll do the scatter plot, prestige 80 by educ first. Then I'll do the linear fit plot with prestige 80 and educ second and put that on top of the first one. Let's go ahead and see what that looks like. And push this out. So you can see that these two graphs are identical. They have the same x-axis and y-axis. The only difference between them is that we've added this linear fitted line on the graphic on the right, and Stata automatically added a legend, so the two graphs don't line up exactly right. The one on the exactly correctly. The one on the right is a little compressed top to bottom. We'll play with that legend in a minute and show you how to move it around the graph, and that's very similar to what we did when we looked at bar graphs. So there's our fitted line, and we can see this relationship is positive, that as when we look at conditional values of years of education, as we increase years of education, we see an average associated increase in occupational prestige. We can do a bit more, and I'm going to show you now. We're going to superimpose 3 graphs, because I have a suspicion that the relationship between these two variables is not linear, and that's what the LFIT graph shows us. So now I'm going to make 3 graphs, and look at the difference between a linear fitted line and a quadratically fitted line. Notice now I've gone to using the pound to limit semicolon and pound to limit CR block so that I can make my Stata code more readable by splitting up my command across lines. Stata expects a command to be all in one line unless you change the delimiter, which I've done here to a semicolon. And so Stata now understands that my first command begins with the G in graph and ends with that closed parentheses in the replace sub option, and we have the semicolon indicating the end of the command. So let's look at lines 11, 12, and 13, which is where most of the work is going on. First of all, we're going to do a linear fitted plot looking at prestige 80 in education. Then we're going to look at a quadratically fitted plot, so that's line 12, that's the Q fit for the same two variables. And finally, we're going to look at the scatter plot of prestige 80 in education, and I'm going to call this scat1 for scatterplot 1. Now you'll notice I have a comment in my file here that says order matters, and that's going to be clear after we look at another example. Sure enough, my suspicions are correct. The fit of this, the relationship between these two measures really isn't linear, it's quadratic. That is, there's kind of a very small slope for low values of education, and it ramps up fairly quickly and then actually looks like the linear fitted line once we get up to about 9 or 10 years of education. So let's go ahead now and start improving upon this graphic. I said there's a couple of ways that we can address this notion of the banding of all these cases being, these points and cases being placed on top of each other. So there's an option in Stata called Jitter. Let's go back and look at our program. So I've just copied that line of code above and I've added a single option under the scatter plot. So I'm not doing any options for L fit and any options for Q fit. I'm adding an option for the scatter plot. And so you see after EDUC I use a comma to delimit that what's before is the command and what comes after is the option. And I'm using jitter and I'm giving it a value of 7. Go to the help manual and look up graph two-way scatter and look at the jitter option and you'll see what the range of values are. But what this is going to do, it's going to take each point plotted on our graph, those are XY coordinates, and it's going to introduce a little bit of error or a little random perturbation and then plot those randomly assigned values. Now it's not total random assignment, it's not assigning a point to be anywhere on that in that XY space, but it's just going to move it around just a little bit so that the points aren't lying on top of each other. So let's go ahead and highlight the block of code that uses the jitter option and see what our graphic looks like. Well, I'm not very pleased with this graph, and as I said in the comment, that order matters. So here's what's going on with Stata. Stata creates these graphics in the order that you list them. So I'm making my L fit first, my Q fit second, and my scatter plot third. The scatter plot is laid over my two lines, and because of that, and because I'm jittering and spreading those points around a little bit, I'm occluding the lines underneath. And by that I mean it's obstructing them or making them difficult to see. So what I need to do to really improve this graph a little bit is I'm going to simply change the order of the graphs, and I'm going to lay down the scatter plot first and then my linear fitted line, and then the top graphic will be the quadratically fitted line. And that's shown in lines of my program, line 22 through 26. So we'll highlight and execute that. So a couple of things to notice here. The most obvious difference in these two graphics is not really that I've brought those lines to the front, although you can see it a little bit. It's that the colors of everything have changed in the graph. I addressed that in another video. Stata has styles that it applies to each graph, and they're in a rotation. It uses style 1, which has a certain color for the first graphic, style 2 for the second, which has a different color, and style 3 for the third graphic. And often you want these colors to be different to make each graph stand out a bit. Here we've seen that our points have gone from green to blue, and our lines have swapped colors, have gone, the quadratic line went from maroon or cranberry to green, and the fitted line went from blue to red. So we're just sort of, by changing the order, we've reassigned these colors. I'm not going to worry about that because when we get to the end of this tutorial, you're going to see I can control all of these colors individually. The big difference between these two graphs, although it's subtle, is that those lines now are lying on top of the points. They're not hidden behind them or they're not occluded by them. Now let's go ahead and move on and see if we can improve on this graphic and make some of these aspects a bit more obvious to us. So the jitter option is something I use fairly frequently, but let's look at some other options that are very useful. Now these are options not to the total graph, but to the specific subgraphs. So looking at line 31, you can see there's our graph two-way that will do the scatter plot for these two variables. I've increased the jitter from size 7 to 10 to spread those points out a little more. And I've added an M symbol option and an M color option. So if you go to Help Graph Two-Way in your online help file, you can look that these are marker options. I'm changing how the markers are presented. The M symbol OH will make the markers smaller. So instead of having these big blocky dots pointed, we're going to make them a little bit smaller. And then the H says to make them hollow. So that's a lowercase o, lowercase h. Smaller and hollow. Then the M color is going to change that outline of those dots from that dark navy blue to a lighter gray. That should make those points recede somewhat into the background. There's other ways of accomplishing this as well. For example, you can change the size of each point plotted, and sometimes I'll use an M size option, and within that I'll specify that the size of the points be tiny. And then they're just sort of little pinpoints on my graphic, but if you have thousands of points, it does allow the white space to show through and allow you to see the lines very well. But here I'm just going to take this M symbol OH, and there's a lot of different ways of showing what your graphics are, or changing the symbol for your graphics. Now look at line 32. Here we have my linear fitted line. I'm going to use three options here to change what that line looks like. The first one, the L width option, is going to make the line thicker. It's going to change it from the default to something more visible. There are lots of options for thicknesses here, all the way down to minuscule, hardly visible, to so thick it'll obscure almost all of your graphics. So there's a lot of flexibility here. This is the one I think is going to work best for me here. I'm going to change the color of the fitted line. So the default color was determined by the styles, and we know that our first three styles are cranberry and blue and green. But I'm going to now specify that that line, the linear fitted line, be colored gold. The gold should look pretty good against the lighter gray dots. And then finally, I'm going to take that line, and instead of having a solid line, I'm going to change the pattern of a line to dash. Again, if you go to the help manual and look up these options, you'll see that there are lots of different patterns we can use, lots of different colors, and lots of different thicknesses. The Q-fitted line shown in my program code in line 33 is going to assign the same options. I'll make the line thick by the L width, but I'm changing the color to red. I really think this quadratic fit is important. It really shows the nature of the relationship, and I want this to stand out, so I'm going to make it a bright, bold color over these gray graphics. And again, I'll make the line a dashed line. Let's go ahead and highlight this line of code and see what it looks like. So I'm pretty happy with this. I think it accomplishes what I wanted it to do by making these lines stand out, by making the points recede into the background. But you may still find the points distracting. And there's really no reason that we have to plot the points. That is, these fitted lines are giving us a description of what's going on average in this relationship between these variables. So if you look at the next couple lines of code, particularly between lines 38 and 39, you can see that I'm now going to create another plot, but I'm not going to plot the points. I've dropped the scatter plot, and I'm just going to plot the fitted lines. Stata is perfectly happy with this. And when I highlight these lines and produce my graphic and put them side by side, you can see that we do get a good summarization of the data with the graphic on the right. Now you'll notice they're not identical, that the graph on the left is a bit squished down, and there's two reasons for that. One reason is the legend is taking up more space. The legend has 2 rows in it, and the graphic on the right only has 1. The other is that in plotting these points, there's a lot of variability in these points. That is variability on the y-axis, and Stata had to leave enough room to get all those points onto the graphic. On the graphic on the right, since we're not plotting any of those points, Stata could show a more compressed area. So you can see that we're now going from 10 to 60 on that y-axis compared to, roughly call it 35 to 100. Now, again, I'm going to propose to you that these kinds of graphs, and spending little time, we can produce a pretty good graphic very quickly. It's one of the things I really appreciate about Stata. I can look at my data, visualize it very quickly to see what's going on. Producing the final publication graphic, however, takes more time. And I think of this as triage. I simply don't go through all those options and fix up and make a beautiful graph until I know I have something worth showing to people. So let's close this. And let's look at a more extended piece of code, which I would say is publication ready. Now, this is a subjective thing, and these are the kinds of, this graph that you'll see are the kinds of things that I like. I'm going to go ahead and run this, and then we'll look at some of the sub options in here to see what they do. So let's go look at some of the program code. You know, again, if right at the top I have my graph two-way and I have my scatter, L-fit, and Q-fit plots, and within those plots I've selected the options that we showed earlier. So I'm jittering, I'm changing the symbol to OH, to a circle, small circle and hollow, and you'll notice I've changed my color here to GS9. So Stata has this scale, it's a grayscale, GS is for grayscale, and I've chosen something sort of in the middle that I thought looked pretty good with the colors laid on top. My options for the L-fit and Q-fit are to make the lines thicker, to make them different colors, and to control the colors that they are, and to change the pattern, the default pattern, from a solid line to a dashed line. I've added titles, and there's one nice little wrinkle in the title here. If you look at the main title in line 49, and you'll see that within the title option, I actually have 2 titles. I have relationship between occupational prestige, and you can tell it's a one title because it's enclosed in double quotes. And then I have a space and it says and years of education, and that's also enclosed in double quotes. What Stata will do in one title command when it sees 2 separate titles is it'll put them on different lines. So this was kind of a long title and didn't really fit on my plot very well, and I decided to split it across 2 lines. I have other options here. I can use a sub option to the title option and change the size of the text. And if you're thinking about this now and understanding that everything's configurable, not only could I change the size of the text, I could change the color and the type of font and so forth and so on. Again, lots of nice fine adjustments we can make. But I simply wanted this to fit on one line. Another thing I could have done is instead of using only the title, I could have added a subtitle and had the first, the relationship between occupational prestige, remain as the title, and then the and years of education be a subtitle, which would appear underneath, so it goes title, subtitle in order, and would be a little bit smaller. But I'm pretty happy with this outcome. I've also added titles for my X and Y axes. So I'm using an X title and a Y title to change the axis titles. And I'm making them education and prestige. The default, I believe, is to ignore the Y title, and for education to use the variable label, which was kind of long and clunky, and this makes the graph less cluttered. And then finally, I'm using a note, which is another kind of title, and I'm adding my source and the year of my data. Now in lines 54 through 57, all of that code is simply to work with the legend. So I'm doing a lot of different things here with the legends, and this is something that I can't teach you every combination of option here. There's just too many of them. but I can give you an idea of what some of the ones do that I like, and then you need to go play with this command with your own data and again produce the kind of graphic that you're happy with. So within Legend, first thing I'm going to do is use the option to col 1. I'm going to change the legend, which is typically given in a single row, and I'm going to make it into 2 rows. Then I'm going to assign the position of that legend. Ring 0 means to put it inside the graphic region. The default is to be outside the graphic, and it takes up more space, and I think I can get a bit more I can make the graphic larger by putting it inside. I was lucky enough to have space in the upper left-hand corner. I wouldn't put it in the lower right-hand corner, for example, because it would cover up points down there. It's pretty much left alone up there in the upper left. I'm going to use the position 11, which says once I decide on the ring inside the graphic, where do I want to put it using kind of a clock notation. We can go from 12 o'clock to 1 o'clock, 2 o'clock, 3 o'clock, and this is 11 o'clock, which puts it in the upper left-hand corner. And then finally, you'll notice, you remember in some of the other graphics, we had 3 different legends. We had the observed values and then the 2 fitted values. I'm pretty certain it's obvious to people that those hollowed out points are the observed values. So the order option allows me to specify, first of all, what gets put into the legend. The first thing was the observed values, the second is the linear fit, the third is the quadratic fit. And so what I've done is I've specified, well, just show us 2 and 3. And I'm not changing the order of 2 and 3, although if I wanted the quadratic fit on top, I would have said order 3 space 2. Now, I didn't like the labels that Stata automatically assigned to these things, and so I'm adding different kinds of labels. For example, label 2 is going to be now linear fit, and label 3 will be quadratic fit. And then in the legend, Stata, the default is to put a black box around your legend, and I thought that was a little intrusive into my graphic, so I'm using this region option to change the line color of the box to be equal to white. Last thing I want to point out to you, in line 58 is a graph region option. So this affects the area outside the plot region. The plot region is where the points are and the fitted lines. So that's everything out there by the X and Y axes. And in earlier graphics, you've noticed that the default in Stata is to use this kind of nice little blue color, which isn't too bad. But again, over the years, I've become more interested in kind of uncluttered, sparse graphs. And I like the way my colors and these lines pop out. And I don't want it to conflict with a color outside the graph. So I can make adjustments to the graph region, for example, changing the color of the graph region using the graph region option, and then within that changing the color to white. Of course, I could have made it lime green or gold or any other color I wanted, and in another video we'll show you that there's just a lot of ways we can adjust the colors. The colors are almost infinitely adjustable, so you could get colors in your graphic to match the colors of a poster if you're doing a poster for a presentation. I appreciate you watching the video. I hope it was useful to you. If you have any questions, please don't hesitate to contact me. I'll do my best to answer all the questions, and we hope to see you at our next video session.
Then it's code in the day to give the keyboard a punch, then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean, and it's, oh boys, can't you code it? Program it right. Nothing ever happened.